Sure. That one is, let's go over something similar to that quick. If I tell you angle A plus B equals 90 degrees, what does that tell me about angles A and B?
And add together, 90.
Yeah. Complements, right?
45, 45, yeah.
Doesn't have to be 45, 45.
Well,
Could be 1 and 89 for all we know, but they're
Yeah.
complements. Which tells us that the sine of angle A equals cosine of angle B, and the other way around. If I tell you that the sine of angle B equals 0.6, cosine of angle A have to be. Because the sine of one has to equal the cosine of the other because they're complements. What's the secant of angle A have to be? Secant of angle A is the reciprocal of the cosine of angle A. Cosine of A is 0.6, so it's 1 divided by 0.6. Oh, the sine of angle A. Well, I know sine of angle A squared plus cosine of angle A squared has to add up to 1 squared, or just 1, in other words. And I know that cosine of A is 6. And then for the cosine of A. Cosine, or 0.6 squared, 0.36. Now I have to solve that for sine of A, so I'm going to start by subtracting the 0.36. Sine of A, still all squared, equals 1 minus 0.36 is 0.64. How do I find the sine of A? Third row. Square root of 0.64. Sine of angle A is 0.8. Well, the cosecant of angle A. Sine of A. Okay. Sure. 5. Tangent of angle A. Tangent of A is the sine of angle A divided by the cosine of angle A. Sine is 0.8, cosine is 0.6. Well, the tangent of angle B. Tangent of B is the sine of B, cosine of B, right? Or 1 over the tangent of A is its complement. But let's look at the sine of A here, sine of B. Sine of B has to equal the cosine of A, which is 0.6. Cosine of B has to equal the sine of A, which is 0.8. Tangent of B is and of B. Cosine. Okay. Makes sense. The secant of B should equal the cosecant of A because they're complements. That should be enough to get you through those problems and corrections. Any questions on all that mess? And that's symmetrical. Or called a 912 slope. That's a 912 slope. How would we find this angle now? Call it angle alpha. Well, that's the same angle as if I took my slope and I made it into a right triangle like this. This side would be 9, this side would be 12. This would be that equivalent angle. Has to be similar triangles there. That angle, the 9 is the opposite side, the 12 is the fixed tangent. Tangent of an angle equals the opposite side divided by the adjacent side. Here, the angle is alpha, the opposite side is 9, the adjacent side is 12. How do I find the angle? Be 6.87 degrees. .87 degrees. Now, since we said this is a common truss, the slope is the same on both sides, this angle over here would be .180 minus the 236.7. This is back to something we did earlier in the semester. Dual slope truss. Let's say I have a dual slope truss here that is 1812 slope on one side, 612 slope on the other side, and a 36-foot span. I want to find height, span here, I'll call it X, the span of the 1812, and over here I'll call this Y, the span of the 612 slope, the run of the 612 slope, or the 1812 slope. I'm going to find this angle. What is it? 106. So the slope is 1812. The heel angle, which is what this is here, is always just the inverse tangent of the slope. Inverse tangent of 1812. gives me 56.31 degrees. I'm going to find this angle over here. At that slope of 612, that angle is the inverse tangent of 612. I have 7 degrees. Angle up top, 95.12 degrees. How do I know that? Well, because I have to add up to 180. Now from here, this would be a lot easier if I gave you one of the top chords. Without that, it's going to turn into a system of equations again, just like it did when we used the slopes to do this. However, it'd be a little bit easier simple system of equations. What I'm going to do here is I am going to give you one of the slopes. I'm going to give you this slope over here is 16. Once we know that, the rest of this actually becomes pretty easy. I'm going to find x. X. So this angle here is 56. How do I find x? Hypotenuse to 16.225. X would be the adjacent. Hypotenuse and adjacent make cosine. Cosine of an angle is adjacent over hypotenuse. Cosine of x over y. Since we're looking for a missing side, I'm going to put this over 1 to make it a proportion, so I can cross multiply divide. Cosine, 36.31. 8.99999, in other words, this is 9. X is 9 feet. What do we have to do to find y?
Subtract 9.
Got it. 36 minus 9 gives us 27. And you can find h by simply doing the square root of 16.225 squared minus 9 squared. H is all that stuff make sense to you? So the next thing we're going to do was a huge fad in construction a few years ago. It's thankfully has settled down a little bit. It was angled attached garage. Now this first one I'm going to do, I'm going to say this here is 36 feet. This over here is also 36. I am going to say this length up here, this wall, about 72. One thing I still need to know is, what's our angle here? Let's call that angle 130 degrees. The rest of the construction, where appropriate, would be right angles. So those four corners are right. First off, what does that tell me about this angle right here? 130 degrees. Got it. Opposite sides of that house need to be parallel. Now the next part I'm going to do can only be done because these two spans, or those two distances, are the same, 36 feet. Put it across here. Because those spans are the same, I know that that cuts this angle in half. That means I can cut across here like this and make that right triangle. Right angle, 5 degrees. Do I know any of the sides of that triangle?
36.
Right there. What I need to find that distance. Call that distance A for now. Well, according to my 65, A is what side of that triangle? Right next to it. 36 is the opposite. We are dealing with a tangent. Tangent of 65 degrees equals the opposite side of 36 feet over the adjacent side, which is A. We're looking for a missing side. We're going to make it a proportion. So we put the tangent over 1. Now we're going to cross, multiply, and divide. So it's 1 times 36, which is 36, divided by the tangent of 65 degrees, gives us 16.79 feet. This distance here, 16.79. What does that tell me about this distance over here?
Same.
It's the same, 16.79. Does that tell me about this distance right here?
Yeah.
72.
72 minus this.
16.79. We got it. 55.21 feet. How's about this one over here? Minus 16 points. Gives 43. Now we can find the area of this real easy. I'm not even going to actually do it. We have this shape here, which is a rectangle, 5.21 feet by 36 feet. We have these two shapes here that are both triangles, 16.79 feet by 36 feet divided by 2. Of course, there's 2 of them, they're both the same. And we have this piece over here, this third piece, 36 by 43.21. That area is really easy to find. Finding these front dimensions up here is not that terrible to find either. But remember, I stressed those spans being the same is what made that easier. What happens if those spans are not the same? Let's say we got 40 foot here on the house, 28 feet on the old garage. The old angle here is 120 degrees. I'm going to call this back here 80 feet. Over here we'll call I want to find the area, but I also want to find X and Y. Probably because I want to know is Y large enough to even put a garage door over there. 56 feet looks like a long ways. Might not be that much. Probably will be like 18. Because these spans are different. We cannot just cut it that way because this angle's not going to be split the same, is it? So the way we have to cut this one, cut here, we're still chopping off those rectangles. But you can see this distance, definitely not the same, very different. I'll label this one A, this one little b. And we do still know that this angle is 120 degrees. Those angles are still the same. And the way we're going to cut up this center piece here, we do this. That's going to give me, first off, is this blue triangle. And the one I'm actually going to work with first is the green triangle. So, this is 90 degrees. What's this angle here? 120, 90, and 90. Add up to 300 out of 360. That one's got to be 66. I know that this side over here is 28 feet. That's from this end. This side over here was 40 feet from the other end. How do I find this side right here? Both cosines. You got it. We got two sides and the angle in between them. The length of that side is going to be the square root of 40 squared plus 28 squared minus 2 times 40 times 28 times the cosine of 60 degrees. I calculated it out yet? 35.55 feet. I'll run it through again. For 40 squared plus 28 squared. It is 35.55 is what I get. Now, to find the other piece, other triangle over there, all we know about that right now is this is 120 degrees. To do anything with that, well, now we do know that this is 35.55 feet. We don't know anything else about it. We need to know either one more side or at least one more angle. Guess what? We can find the angles. By going back over here, let's say I want to find this angle. Why would I want to find this angle instead of this one? Technically, this angle here really shouldn't be obtuse, but we're playing it safe, using a smaller angle. So if I'm finding this angle here, I have 35.55 over the sine of 60 degrees equals 28 over the sine. I'll call that angle alpha. So I'm going to cross multiply and divide to find the sine of that angle. Minus 60 times 28 divided by 35.55 gives me 0.6821. Sine of that angle, I do the inverse sine. 43 degrees on the dot. Alpha. Alpha is 43 degrees there. Now I know a bunch of things. First of all, I know this angle here is 180 minus 60, 77 degrees. But remember, the triangle, that the other triangle we're looking at used to be attached to it like this up here. This was a right angle. That means this angle right here is 90 minus 43. This angle over here is 90 minus 77, or now that I have those angles, I can find sides A and B over here, can I? 5.55 feet over the sine of 120 equals A over the sine of cross multiply and divide there. 5.55 times the sine of 13 divided by the sine of 20. Thus, 9.23 for A. B is going to be considerably larger, but it's going to be a similar proportion. 35.55 over sine of 120 over the sine of 7. That means up here, this is 9.23. Obviously, I drew them way out of scale. But that means this up here, y is 56 minus 30.02, 5.98. So yes, that is big enough to get an overhead door. And then x is 80 minus 9.23, 77. 28. And now we can find those areas. Got x and y. 70.77 for x and 25.98 for y. We can find the area. How do I find the area of piece 1 there? $40 times 70 point equals 831. Is that what it comes up to be? $30.8. 2830.8. One of the pieces. I'm going to stay easy. I'm going to jump over here into piece 2. How do I find the area of piece 2?
Times 25.
Perfect. 28 times 25.9. $727.44. Now, piece 3 is going to be this one right here. And we've done some things in the last week to make finding that area considerably easier. We have 2 sides in the included angle. Area of piece 3 is 40, 28. Trig area formula. $34.97. Where's going to be this one over here? Same thing, really. 9.23 times 30.02 times the sine of 120 over 2. $19.98. So our area is found by adding stuff up there. $1,163.19 square feet. Does that look right? What do you think? Huh? I realize we're getting, as I mentioned before, we're getting into stuff that's very complicated. Up here, if you did not see, you could divide this across here. this was pretty much an impossible problem. That in mind, that is why all of the quizzes and tests from here to the end of the semester, I am expecting you to work together. Not expecting you to sit down on your own and print this out. This is stuff that's handy to know, but you would probably survive in the business without it. But it's also very applicable if you know how to do it. It makes life a lot easier if you know how to do it. So there's that quiz out there for you. I think it's called Quiz 423, if I remember right. For you to work on. And there are 2 worksheets out there to work on. We are going to work on problems off of these 2 worksheets more tomorrow in class, so they don't both have to be done or anything like that. We're going to be picking away at them here. With that, I'll give you guys the last half hour of class here to work on stuff you would like. I'll be on the